The mysteries of ancient Egypt have been at the center of scientists' attention for several centuries. Among the many cultural architectural monuments left by the lost civilization, the most famous certainly are the three giant pyramids located on the stone plateau of Giza, near Cairo. Who, when and why built these cyclopean tetrahedra? It would seem that academic science has long answered these questions. Perhaps the only unresolved problem is the answer to the question of how they were built, or rather, how the ancient architects processed and moved huge stone blocks. Numerous technical solutions are offered in a variety of ways, but each of them contains many weaknesses, and all attempts by researchers to test the theory and practice have ended unsuccessfully. Meanwhile, in the latter half of the 20th century, chemical engineers made a discovery that provided a clue to the technology used to construct pyramids. Moreover, an independent examination of samples of building stone fully confirmed the scientists' correctness. The mystery of the ancient pyramids has been solved. It seems that this discovery should have been sensational, and the scientists who made it could have claimed the most prestigious scientific awards. However, things turned out differently. The scientific world answered with complete silence. Egyptologists did not seem to take notice of the discovery, and they still do not want to notice it. For historians, archaeologists, art historians, and just for tourists, Egypt can be considered one of the most bountiful places on the planet. Huge stone sculptures, the ruins of ancient temples, and mysterious hieroglyphs on the walls of palaces have been exciting the imaginations of researchers for hundreds of years. However, the main attraction in Egypt is the pyramids. There are over 80 of them. They stretch along the Nile River for a chain of 50 kilometers. This ensemble is dominated by monumental structures on the Giza plateau near Cairo. The pyramids of Cheops, Khafre, and Menkaure were known as the Great Pyramids and were included in the list of the so-called Seven Wonders of the World, and for good reason. The height of the largest of them, the Pyramid of Cheops, exceeds 140 meters. It consists of more than 2 million stone blocks, each weighing between 2.5 and 15 tons. Indeed, it is difficult to surprise a modern person with anything, even with the Great Pyramids. And yet, the question of how people were able to build such a thing many centuries ago still keeps scientists awake today. Egyptologists have proposed many techniques for constructing these colossi and have periodically tried to put them into practice.
There have been numerous such attempts. The Americans and the Japanese have tried. Such attempts can be divided into several groups. The first category of attempts deals with the manufacturing of some wooden mechanisms, as well as various huge pulleys. The ancient slaves allegedly entwined huge blocks with a network of ropes and cables, lifted them, loaded them onto sled with skids, and then dragged them for tens of kilometers.
However, the researchers quickly became convinced that, from a technical point of view, all these theories are, to put it mildly, controversial. All attempts to construct, even diminished and highly simplified replicas of ancient structures utilizing this technology, always failed. Although the ancient builders of the pyramids dealt not only with relatively small blocks weighing several tons, but also with real colossi amounting to 500 tons. For example, the famous Temple of the Sphinx at Giza is made of such imposing bricks. It is difficult to imagine that the Egyptians could even move this block from its place, let alone transport it, according to Egyptologists, for tens and hundreds of kilometers. And here lies a giant block not far from the Pyramid of Khafre. The well-known Egyptologist Jean-Philippe Lauer suggests in his book, Mysteries of the Egyptian Pyramids, that huge stone blocks were moved on wheels. However, this proposal is also highly questionable. Even today, transporting stone blocks of 500 tons would be an extremely difficult technical challenge. After all, what prevented the ancient Egyptians from dividing them into several parts to make their job easier? Indeed, as historians assure, blocks of various sizes were successfully cut in the quarries of ancient Egypt. A similarly difficult question is how these multi-ton bricks were raised. In his book, Jean-Philippe Lauer criticizes one lifting technique of these blocks by means of wooden mechanisms, and defends another, the construction of earth ramps next to the pyramids along the slopes of which heavy blocks were allegedly dragged. But in Alberto Carlo Capicecchi's book, Art and History of Egypt, 5,000 Years of Civilization, the technique of using wooden mechanisms has been described as the most plausible and tenable. There is also a theory that the pyramids were not built from the bottom up, but from the top down. At first, they were cut out of solid rock, and then lined with stone blocks. Even though the proposed methods of construction are theoretically feasible, firstly, they are incredibly time-consuming, and besides, they cannot answer all the questions. Some ancient Egyptian architectural puzzles remain unsolved. All the stone blocks in the walls of the pyramids, both the small ones and the largest, are almost perfectly fitted to each other. The gap between some of them is not more than half a millimeter.
Here, as with the Pyramid of Cheops, we see the perfect fit of granite blocks. Moreover, they are large blocks. They converge at perfectly right angles, and the seams between them are so tight that not even a needle can be inserted into them.
To achieve such a result, diligence alone is clearly not enough. Special tools are needed and unique, even by modern standards, stone processing technologies. How could the Egyptians make such a fit? Representatives of the scientific world only shrug their shoulders and continue to talk about the mysterious greatness of the ancient Egyptian civilization.
And in some cases, it's ridiculous. For example, I noticed that in the Sphinx temple one of the inner corners was not made by joining two blocks, as is usually done in stone construction, but by making a corner in the block itself. That is, the block has an L-shaped section, slightly bends 5 centimeters to the next wall. Imagine what it means to make such a stepped block. This means that one needs to remove the surface of this entire block, deepening it by 5 centimeters. The idea is completely crazy, and it does not fit into the framework of common stone construction.
There is one more question. Why did the ancient architects complicate an already difficult task for themselves?
I must say that the authors of these theories themselves understand all their inconsistencies. That is why, in serious scientific books, you can find, in our opinion, a completely frivolous statement that the ancients had almost semi-mystical means that have since been lost, which enabled them to make huge stones rise into the air and move by themselves in space. This already belongs to the realm of fantasy, but I reiterate, these words are heard because the authors of the theory understand that, unfortunately, they can offer nothing more reasonable.
In such a situation, it can be assumed that some highly developed civilizations, for example, the inhabitants of the legendary Atlantis or even aliens, had a hand in the creation of huge structures. What if the question was phrased differently? It would still be no less paradoxical at first glance. If the ancient architects were not able to carve and heap huge stone blocks on top of each other, then how could they still build the Great Pyramids? Could they have used some other construction technology? How to build a structure of this magnitude today, skyscrapers, for example, obviously using concrete. If the pyramids were built today, then the main building material would most likely be concrete. In appearance, the blocks of the Egyptian pyramids could pass for concrete, but the production of this building material involves the use of very sophisticated modern technologies. For example, take the manufacturing of cement, which is the main component of concrete. At the first stage, the rock is ground with the addition of water and turns into a liquid mass. Further, this mass is subjected to gradual heating in special furnaces, and complex physiochemical transformations take place in it. After rapid cooling, a semi-finished product known as clinker is obtained and then ground again. The problem is that the firing stage requires a temperature of approximately 1,500 degrees Celsius. Only under such conditions does the material acquire the necessary properties. It is unlikely that the ancient Egyptians had such furnaces, and therefore such concrete. On the other hand, since ancient times, mankind has used something similar to concrete or cement for construction with stone and brick.
People have long understood that stones cannot stand well on their own. They must be bonded either with cement, or with lime, or with egg yolk and protein. They hold very tightly.
At different times in different countries, wax, resin, wheat flour, sheep's cheese and garlic juice were used in the manufacturing of cement mortar. Can such ingredients be used on an industrial scale, not just for bonding blocks, but for manufacturing them? Millions of blocks. So, is concrete still being considered, or has it been taken off the table? The French chemist and professor at the University of Bern, Joseph Davidovits, developed a method for obtaining this geopolymer concrete in the middle of the 20th century. This production does not require the use of complex, modern technologies. Any crushed rock can be used for its manufacture. Concrete hardens quickly at room temperature and turns into an artificial stone. Currently, this technology is successfully being used by American and European manufacturers. The strong point of Davidovits' discovery is that, to create an artificial stone, he proposed using a long-known physical phenomenon, adhesion. Adhesion, from the Latin adhesio, is the tendency of dissimilar liquid or solid particles or surfaces to cling to one another at their points of contact. Davidovits suggested that his discovery could have been known to ancient architects, including the builders of the Egyptian pyramids. It was Davidovits who put forward a bold hypothesis that the pyramids and other famous structures in Egypt were not at all carved from stone, but were made from concrete.
To make geopolymer concrete, neither high temperatures, nor high pressures, nor modern technologies are needed. All that is needed is to know the exact ratios of the chemicals that are mixed into the composition.
Joseph Davidovits identified 13 components of the building material of the ancient Egyptians. It turned out that all of them were literally lying under the feet of the builders. For example, sodium carbonate is available in large quantities in local deserts and salt flats, and mud from the Nile River contains alumina.
Even now, people are sitting in Cairo on the shore made from the Nile silt, which is not just clay, but a mixture of hydroxides of iron, aluminum, and other substances, including organics, which turn to stone when dried to a hard, stone state. This is an excellent binder.
Look, they made a wall. This is not a baked brick made from Nile silt or just from earth.
A binder is necessary to obtain an artificial stone from hard rocks, such as granite or diorite. But one can manage without any gluing. Soft rocks can be ground into a very fine powder with little difficulty.
Take any rock, crush it to a certain size, and then mix it with the same, finer powder and mix it with ordinary water, and you will get a stone that is practically indistinguishable from natural stone.
So, we can conclude that there were all the conditions necessary for the production of concrete in ancient Egypt. By the way, there is a rather curious ancient Egyptian image on the wall of Rekhmir's tomb in the Valley of the Nobles. It can be reasonably interpreted as a step-by-step description of the process of making concrete blocks. Here are two Egyptians using jugs to collect water from a square reservoir. The third is crushing rock, the next is making a batch, and the resulting mass is being loaded into a basket. Next comes the pouring of a huge block.
In fact, this is not natural stone, but geopolymer concrete, and on the outside it was coated with a layer of a higher quality composition. Well, at least a composition that was slightly different from the composition of the internal one. Because of this, there was a non-heterogeneity along the surface and the skin peels off. Let's see what is underneath this skin. Sand. It can be seen that there is sand here. It is not granite. This is geopolymer concrete.
Let us now recall the main mysteries of the pyramids and see if they can be explained using this concrete technique. The ancient Greek scientist Herodotus, often called the father of history, after traveling to Egypt and communicating with local priests, created a new interpretation of pyramid construction technologies. Here is what he wrote. When this, its first form, was completed, the workmen used short wooden logs as levers to raise the rest of the stones. They heaved up the blocks from the ground onto the first tier of steps. When the stone had been raised, it was set on another lever that stood on the first tier, and the lever again used to lift it from this tier to the next. It may be that there was a new lever on each tier of steps, or perhaps there was only one lever, quite portable, which they carried up to each tier in turn. That is a pretty vague description. What kind of levers was it and how was it raised? But in any case, is it conceivable to lift multi-ton stone blocks with the help of wooden levers? Egyptologists declared without a shadow of a doubt that Herodotus' version was erroneous. However, if we assume that we are discussing geopolymer concrete, then we have a completely plausible description of a form into which the concrete mix was poured. That is the most common construction formwork. Formwork is a removable wooden or metal mold used to form concrete into structural shape of a future concrete or reinforced concrete construction.
If you carefully read this text, it becomes clear that Herodotus describes precisely the wooden formwork, with the help of which the stone was lifted, and in a sense the stone grew, because it is clear that if a huge volume of this cement is poured at once, it will dry either unevenly, or it will be distorted. It is clear that these stones are built up, that is, layer by layer, letting it dry.
These layers are clearly visible today where the stone blocks are exposed. If it were natural limestone, for example, as in the wall of the Cairo fortress, then the layers would have to be even and parallel. Limestone is a sedimentary rock. Its layered structure is formed as a result of the sedimentation on the ocean floor of various substances, which gradually build up parallel layers millimeter by millimeter. But in the blocks of the pyramids and temples, a completely different pattern is visible. Here is a fragment of the Cheops pyramid block. This is a chip in the upper corner of the block. On the side surface of the block, a mesh pattern is clearly visible. Where did it come from? There is a simple explanation. This is a mat imprint, which was laid inside the formwork where the block was cast.
Moreover, as if there was one mat from left to right, and the other overlapped it, from right to left in two layers. This is possible only if it was part of the formwork, the mat that covered the formwork.
But the upper surface of the block is pretty uneven and bumpy. This is exactly how concrete should set. Today, to avoid such defects, special vibrators are used, but it is unlikely that the ancient builders would have anything like that.
If all this had been carved out of stone, then, certainly, the surface of the block would have been treated to all look the same way, and it would have had a uniform character. The formwork traces mean that we are dealing with concrete.
The question arises why no one pays attention to these patterns? Because in the lower masonry of the pyramid, which tourists usually pass by, there are no such marks. But if you climb higher, this fragment of the pyramid block was taken from a height of more than 50 meters. There, similar traces are visible on all blocks. Obviously, it can be assumed that the ancient Egyptians processed stones differently for different levels of construction, but there is another explanation as well. Pyramid blocks are quite soft. Their hardness can be compared to the hardness of gypsum or a human nail, so the sandstorms frequent in these places could well have polished off the surface of the blocks and destroyed all traces during a long time period.
Sand rushes to the pyramids and plays the role of an abrasive block. It rises to a maximum of several tens of meters, 20, 30 to 50 meters, and traces of formwork were found higher than that.
By the way, traces of mats can be seen not only on the blocks of the pyramids.
We are in the courtyard of the Temple of Esna. Here is a stone bearing clear traces of concrete origin, remains of a reed mat frozen into stone.
Now let's try to solve another mystery. When building pyramids and temples, how did the Egyptians process blocks so that the gap between them was minimal? In many places, these gaps seem to be just regular scratches on the surface of the stone. Egyptologists cannot give a clear explanation for this phenomenon, they just calmly admire it. Well, it is really difficult to imagine how the Egyptians smoothed out multi-ton stone blocks. In addition, before fitting the blocks to each other, they must be cut from solid pieces of rock. According to Egyptologists, they did it with copper saws.
Has anyone ever cut a wood with an ordinary steel spring-set saw? Sure. Has it ever gone without saw damage to wood? Never. The saw always pops out of a groove. Are there such damages on the stones of the Pyramid of Cheops? No. Nobody has ever seen it anywhere. Further, why do we set saws? That is, why do we bend away saw teeth? To allow the blade moving without binding, getting stuck. And how do you saw with a copper strip without binding in the stone? It will get stuck right away. By the way, did anyone ever see these saws anywhere in any museum? There are none.
But if the blocks were not carved, but molded, then everything falls into place. Each next block was formed by adding a wooden formwork to an already finished block.
You grout a new portion of concrete and water, and then these two blocks literally merge with each other.
In principle, the ancient builders could have made the walls monolithic. But in this case, the pyramids would sooner or later burst and collapse under the influence of various temperature drops and internal structural stress. In order for the structure, as they say, to breathe, it was apparently divided into separate bricks, so the pyramids still stand today. In their centuries-old walls you will not see a single crack, but one can find quite unexpected things. For example, in the masonry of one of the satellite pyramids, located south of the Pyramid of Menkaure in Giza, rather strange cavities immediately catch the eye.
This pyramid is made up of blocks that are covered with a hard crust, but the internal composition is much softer. This is not the case for natural stones. But for concrete blocks, this is normal, because in order to make a block, they could use a cheaper compound for the inner block and a more expensive and stronger one for its exterior. It can be broken by hand, just by hand. This is inside the hollow. This is the internal composition of the stone. If we try to damage this crust, the external composition, then no chance, it is out of question to break with your hands.
Inside the stone is quite soft and easily crumbles with a finger, and on the outside there is a hard porous crust, hardly yielding even to a knife blade.
Can a natural stone have a hard coating and a soft interior? Moreover, the stone processed, sawn or cut in a quarry? In our opinion, no, it is out of the question. But if it is concrete, then, obviously, substances that give it increased strength could well have been added to the surface layer of concrete.
And again the question arises, why did others not see this?
They were taught that limestone blocks were cut out on the other side of the Nile River, as shown in specially staged supposedly documentary films, and then they were transported on barges, on rafts to this side. The limestone over there is different. In that limestone there are a lot of perfectly preserved nummulites, these shells the size of a small coin. And in the blocks of the Pyramid of Cheops, where are these very same nummulites? Where are the organic remains, sea hedgehog of the Eocene epoch? There are none. Moreover, any limestone cracks. I had a hard time finding a crack while wandering around the Pyramid of Cheops, because concrete is amorphous. Concrete does not form cracks and behaves like a substance with the same density and structure in all directions.
In the Pyramid of Cheops there is a monolithic granite sarcophagus, but no one can answer the question of how it got there. It could not be carried through the existing passages and doors of the pyramid, they are much narrower. Think of other mysteries of this kind. For example, in the famous Valley of the Kings, located 500 kilometers from Cairo, not far from the city of Luxor, today, a wide road leads there. Even a car can go there. However, 100 years ago there was no road. The valley where the pharaohs were buried was surrounded by sheer cliffs all around it. And to get inside, one had to go through a narrow hole cut in the rock. When the first French conquerors, headed by Napoleon, got into the valley, they were amazed to find granite sarcophagi in the tombs of the pharaohs. Their dimensions significantly exceeded the dimensions of the only entrance to the valley. Moreover, these sarcophagi, as in the Pyramid of Cheops, were not assembled, not glued from separate parts, but monolithic, because being hit by a hammer they rang like a bell.
The Egyptologists said, well, they were dragged over the mountains, lowered with some kind of ropes. Wouldn't it be easier to widen the entrance to the valley a bit? Because it was not a problem to widen it. Their rocks over there are soft. If you really need to drag such a sarcophagus, why drag it through the mountains? This, by the way, still needs to be proved that this is possible, because such sarcophagi weigh a lot.
If we assume that the sarcophagi were not moved anywhere, but were made in the valley itself from geopolymer granite concrete, then this mystery also gets a completely rational explanation. The method of geopolymerization allows creating not only artificial limestone. Concrete can be made from any other rock, such as granite or even super hard diorite. Joseph Davidovits suggested that the pyramid blocks are not the only ancient Egyptian concrete product. Imitation of natural materials could be used everywhere in the creation of temples, statues, household items. Another Egyptian puzzle with the famous amphorae found in the Pyramid of Djoser gets solved in the same way. They are made from the hardest varieties of stone, in particular from diorite. Modern sculptors do not even try to use these types of stone. Some of them are harder than iron.
The question is how such amphorae could be made by drilling. After all, Egyptologists tell us that it was drilled, that the ancient Egyptians took a block of stone, turned it on the outside to give it the shape of an amphora, and then somehow using copper tools or some kind of stone drilled out a cavity inside. Firstly, it is still not clear with what it was drilled. This requires diamond drills. Even if such a drill is available, how does one drill an amphora through a narrow neck, so that the expansion at the bottom creates walls uniform in thickness?
Moreover, neither the inner nor the outer surfaces of the amphorae have any traces of working with a hard tool. How much time and effort had to be spent to make the walls of these vessels not only uniform in thickness, but also absolutely smooth? The Davidovits discovery completely solves this problem. Not yet hardened geopolymer concrete could be processed on a conventional potter's wheel, like ordinary clay. And this means that the ancient masters did not spend that much time on the manufacture of each product. There is yet another fact that many Egyptologists admire almost superstitiously. We are talking about the depth and clarity of hieroglyphs carved into the hardest rocks. There are no analogues to the ancient Egyptian method of creating images anywhere in the world.
If we look at, say, European, Russian stone carving, which is done on soft stone, we will see that the stone is cut at different angles, a pattern appears, there are some recesses, bulges, edges, shadows of which form the image. Egyptian carving uses a completely different principle. The image evenly goes deep into the stone at a right angle.
Even from modern hard alloys, it is not possible to create tools that would enter granite or diorite like a hot knife through butter. Meanwhile, the chisel in the hands of the ancient master seemed to meet no resistance and did not deviate to the side, even bumping into denser spots. Of course, here one can again embark on a discussion about the craftsmanship and determination of the Egyptian sculptors and once again be surprised at their strange tendency to complicate tasks. Indeed, why go deeper than 10 centimeters into the rock? Why not limit yourself to a modest 2 or 3 centimeters? The inscription will be perfectly readable, but, perhaps, in search of the most plausible explanation, instead of creating more and more myths about some hard-working miracle workers, it would be more productive to return to the idea of geopolymer concrete and assume that the hieroglyphs were not cut, but pressed into not yet hardened surface. Then it becomes clear how and with what the inscriptions were applied.
The Egyptians are geniuses at plastering. The plaster they put on is perfect. The walls of temples, literally, are continuous plaster, on which all these hieroglyphs were made by extrusion. Often this cladding is mistaken for granite, but they do not understand how the inside of this cladding absolutely exactly, as if according to a template, coincides with the material to which it is glued. When plastering, this is usually typical.
And in fact, if we forget that we are dealing with the mysterious, incomprehensible art of stone processing, it immediately becomes obvious that one cannot do without plastering work here.
On many ancient Egyptian granite stones, as well as statues, for example, Sphinx ones, there are these bald spots. That is, the skin peels off from this statue parallel to the treated surface. Undoubtedly, the stone may be layered, but the layers of the stone cannot be parallel to the resulting finished surface of that stone. In order to make a huge granite sphinx, one doesn't need to waste high-quality concrete inside the sphinx.
Finally, one more argument in favor of the concrete version.
In the courtyard of the Dendera temple there is an ancient Egyptian granite slab. An image quite typical for ancient Egypt is stamped in it. This slab consists of granite crystals which are fastened together with a gray powder. This granite can be simply broken by hand.
Science has no knowledge of natural granite, which can be easily crumbled by hand. It seems that in this case we are dealing with an example of a manufacturing defect made by the ancient masters.
The builders chose the binder so poorly that it practically crumbles under your hand.
The Egyptians were people too and could very well be wrong sometimes. For example, when forming the composition of the concrete mass. In any case, artificial origin of the stone is obvious. It is necessary to clarify one more circumstance. How did the builders crush the rock? Why not assume that this problem was solved by analogy with the problem of grinding grain, where mortars, graters and millstones were used?
There is no problem in this. Moreover, the graters in which rock could be ground were found in Egypt.
Hand graters can grind limestone. But how to grind hard rocks such as diorite to a state of powder? It turns out there is a pretty simple way.
We do this in the field every year, when we need to get powder from the hardest rock, but so that there is no iron from sledgehammers or mortars. We just put one stone on top of another and hit it with a third stone.
So, this way, stone on stone a powder is obtained. In this simple way you can get the initial material for the manufacture of objects from artificial stone of any hardness and in any quantity if beating for a long time. All the while finely crushing the entire stone is not necessary. A mixture of powder and small fragments is stronger and makes it possible to speed up production. In addition, the inhabitants of the earth have used another very easy way of crushing since ancient times.
In Yemen, people break grain while riding in a large stone bowl on a swing. In this way, it is possible to grind solid rock with stone on stone in large volumes, rather than in small graters.
Thus, the hypothesis about the use of geopolymer concrete in ancient Egypt takes on a completely finished form and really explains most of the mysteries of the pyramids. And not only them. Baalbek in Lebanon, the English Stonehenge and other similar structures could well have been built in a similar way. But if geopolymer concrete has indeed been used by mankind since time immemorial, then how come the unique knowledge disappeared? The answer to this question is quite obvious. Previously, only a few discoveries became the subject of the public domain. The rest were kept in the strictest confidence. Only a few initiates could know the secret, and in the event of their sudden death, there was simply no one to pass on the secrets of mastery. This is how the technologies for the production of filigree and granulation, and damask steel were lost. But we still know a lot about them, or have at least heard something about them. But why do we not know anything about the unique building material used in the past? Is there really no historical mention of it?
We all know the famous philosopher's stones of the Middle Ages. The alchemists of the 17th, 18th, 19th centuries were especially fond of searching for the philosopher's stone. Of course, the theme of the philosopher's stone itself is very extensive, very ambiguous, and many different storylines are clearly intertwined here.
Traditional science considers alchemy to be a pseudo-scientific direction in the development of conventional chemistry. Its accomplishments include the discovery or improvement of products of practical value, such as mineral vegetable dyes, glasses, enamels, metal alloys, acids, alkalis, and salts. But the main task of alchemy was to obtain the so-called philosopher's stone. According to popular belief, in the Middle Ages they were looking for nothing more than a substance capable of turning base metal into gold. And all real inventions are just byproducts, randomly obtained in the course of this fruitless search. However, science could hardly have existed for many hundreds of years without giving any real return, based on fiction and empty promises. Obviously, alchemists also took on the solution of some practical problems. Moreover, those who financed them should have had good reason to believe that the goal was feasible, that it had already been done before. Meanwhile, in the history of alchemy, it is believed that the secret of the philosopher's stone was known in Egypt. The last person who possessed secret knowledge was a certain Roman named Marianus. The legend says that one day the Egyptian king Khalit gathered his alchemists and demanded to make the coveted stone. However, all their attempts ended in failure. Then Marianus came to the king and easily accomplished the task. The reward for the Roman was his life. All the other alchemists were executed, but Marianus fled, fearing that sooner or later the same sad fate might befall him. Many years later, one of the king's servants nevertheless tracked down the fugitive and asked him to reveal the secret. And Marianus answered his question.
And revealed this secret and said that in order to create a stone, one must first destroy and that it has several components. He called them by some strange words that his companion did not understand.
Subsequently, the alchemists tried to interpret the words of Marianus, but apparently unsuccessfully, since they never got the philosopher's stone. What if we assume that we are talking about the manufacture of geopolymer concrete?
We are by no means declaring that the philosopher's stone is necessarily geopolymer concrete. No. But as one of the possibilities, it is quite probable. And from this point of view, many interpretations of old sources acquire a new clear meaning, which, as we found out, by referring to old books on alchemy, quite often and quite well reproduce the method of making geopolymer concrete.
The technology is as follows. First, one needs to grind the rock, then add special substances, then mix everything and, finally, get the stone. By the way, today we call it artificial stone, and in the past, knowledge in general was considered an art, as well as philosophy.
An artificial stone is obtained with the help of art with the help of knowledge. In other words, we can say, a philosopher's stone is a stone that is obtained with the help of philosophy with the help of some knowledge. And, certainly, such an important invention as geopolymer concrete from which it was possible to make sturdy fortress walls and certain structures, this discovery, obviously, was of the utmost importance. And therefore it is clear that after its loss they tried to stubbornly rediscover it for a very long time, but the medieval alchemists did not succeed in the 17th century. They worked on it a lot in the 17th century and then they abandoned this business, and only in the 20th century it was rediscovered.
Evidently, the bold hypothesis of Davidovits, Fomenko, Nozovsky, and other scientists needs independent verification, and in order to reliably establish what kind of stone the pyramids are made of, natural or artificial, it is enough to conduct a physical-chemical analysis of it, and such an analysis was made by Russian scientists. In November 2005, the research group of the New Chronology Project headed by Gleb Nozovsky visited Egypt. During the trip, new facts were discovered confirming the concrete version, many of which are reflected in this film. In addition, samples of the building material of one of the three Great Pyramids, the Pyramid of Menkaure, were selected. The base of the pyramid, about a third of its height, is lined with what is considered to be natural granite. A fragment of this cladding was provided by Gleb Nozovsky for research.
Here, we will collect it and submit for examination.
Indeed, the stone from which this cladding is made looks very similar to natural, and least of all resembles concrete. This makes it even more interesting to learn the results of the examination carried out at the Institute of Physical Chemistry and Electrochemistry of the Russian Academy of Sciences.
The purpose of the research was to study the structure and elemental composition of the stone-like sample. The sample was prepared by the cleavage method, followed by the deposition of an electrically conductive element on its surface, which was carbon. Carbon was sputtered in a high vacuum while rotating the sample, which made it possible to obtain a thin carbon film on the sample surface.
The sample prepared in this way was examined in a scanning electron microscope. This microscope is equipped with energy and wave X-ray detectors, which allow determining the content of elements with an accuracy of 1/10 to 1/100%, depending on their chemical structure.
As a result of the research, microphotographs of the sample surface were obtained at various levels of their structural organization, as well as X-ray spectra, which unambiguously made it possible to establish the elements that make up this sample, as well as their quantity and other substances.
The results of chemical analysis showed that the percentage of titanium, calcium, sodium, phosphorus, sulfur, chlorine and aluminum is too high for natural granite, and vice versa, potassium and silica turned out to be in smaller amounts than in natural stone. How can this be explained? In appearance, this sample is very similar to a piece of granite. However, any experienced geologist, when looking at photographs taken with an electron microscope, will immediately make an unambiguous conclusion: this is not natural stone. Natural granite has a dense, uniform granular structure. At the same time, the gaps between the crystals of feldspars and micas are occupied by solid quartz. But in the sample taken from the pyramid of Menkaure, the pattern is completely different. The structure of the stone is quite loose. The grains of minerals are unevenly distributed and fastened with some kind of binder, which is absolutely not typical for natural stone. It is the presence of this binder composition that can explain the increased content of titanium, calcium, aluminum, and other compounds in the sample.
Overall, all this shows that we are dealing, most likely, with some kind of building mixture, with some kind of mortar. The base is calcareous or limestone, more precisely. And the additional materials that we see with our own eyes are either the composition of feldspar, or biotite, or just granite.
These facts are already quite enough to draw a conclusion. The pyramid of Menkaure is lined with artificial material. But if you look closely at the photographs, you will find another more than convincing argument in favor of the concrete version.
The presence of some hair-like aggregates and individual hairs, very thin, in large quantities, judging by the photographs, shows that this is a foreign material of organic origin, which has nothing to do with natural stone. And its introduction is possible only during the manufacture of this artificial building material. I suggested that it could be the fine wool of some ram, some sheep that lived there. But it's literally real felt when you look at it on a normal scale. Hair covered with keratin scales. They are visible surprisingly well. The amount of foreign material in this material of the pyramid is grandiose. There is so much of it that it's not even worth arguing about.
Well, these results are not unexpected. Davidovits carried out similar studies decades ago and came to the same conclusion.
It is surprising that Egyptologists do not pay attention to such results, although they have long been informed about this. And Davidovits spoke, and we write. And one gets the impression that Egyptologists stubbornly do not want to listen to the arguments of natural science representatives.
In 1982, Jean-Philippe Lauer, a supporter of the stone version, gave Joseph Davidovits 2 fragments of pyramid blocks and offered for him to prove their artificial origin. Chemical analysis, carried out at once in 2 independent laboratories, unconditionally confirmed the concrete version. On this occasion, Davidovits made a presentation at the Congress of Egyptologists in Toronto, but Lauer, who also came to the forum, for some reason didn't show up for his colleague's speech. He limited himself to a short comment in the press. Not stupid, but impossible. It cannot be, because it can never be. This is the answer of one scientist to another. 2 years later, in 1984, Davidovits appealed to the Egyptian Antiquities Organization for permission to conduct research on the pyramid field at Giza, but the professor's request was rejected. The reason for the refusal was explained as follows. Your hypothesis is only a personal point of view, which does not correspond to archaeological and geological facts.
That is, the refusal was purely demagogic in nature. No scientific arguments were put forward against Davidovits' hypothesis. And in our opinion, this is a clear indication that, in fact, some Egyptologists seem to be aware that any start of a discussion on this topic is fraught with big problems.
Here is another very recent example. In 2006, American scientists conducted an independent study of the substance that makes up the blocks of the Cheops pyramid. Spectral and mineral analysis showed that the building material sample consisted of a mixture of limestone, sand and clay. Experts have now come to the obvious conclusion that it is concrete. It seems that now nothing can shake the almost religious inertia of the conclusions of the representatives of traditional science. After all, Davidovits did not just write books, he proved in practice the possibility of building a concrete pyramid from materials available to the ancient Egyptians.
When you look at the stones of the pyramid, this is what you see. You see either smooth blocks or very crude blocks. And we have replicated all these surfaces just by varying amount of water, which depends on the climate, depends on the weather.
In this way, Davidovits tried to draw attention to his theory, but all was in vain. There is a feeling that modern Egyptologists are trying, by all means, to preserve the beautiful fairy tale created by their predecessors in the 19th century. A fairy tale how millions of Egyptian slaves for many decades, like ants, tossed huge stone blocks and erected colossal pyramids from them. Too much has been written about this in textbooks. Colorful films have been shot. Well, to admit now that all this is fiction? Historians don't want that. But in this case, doubts about their correctness on other issues may arise.
If a blunder is found on one of the pages of a scientific work, and its author, instead of admitting this error, stubbornly defends his accuracy, this is a clear indicator that there are a lot of errors in the work. Indeed, our analysis of the history and chronology of Egypt showed that the history and chronology of Egypt, which is defended by Egyptologists, rests on very shaky foundations, and there are a lot of deep and fundamental mistakes in it.
All history books state that the Egyptian civilization is very ancient and existed many thousands of years ago. But surprisingly, historians never had and still do not have any real evidence in support of this supposedly most obvious antiquity. So the question of how the pyramids were built is by no means the only and far from the most fundamental one, where when answering the representatives of traditional science stubbornly adhere to the erroneous version. There are reasons to assert that the answers of academic science to other questions, when, who and why they built them, are not so well founded, as it seems at first glance.